Welcome to the second part of the DeepTelos demonstration. DeepTelos is an extension to the ConceptBase system to allow for so-called multi-level modeling. ConceptBase is a system for meta-modeling and conceptual modeling. Simply, pretty much like a database system for models. So the part one of the demonstration had no audio, but never mind, I will introduce into the concept in a short way in this second part. So let's go into the demonstration. The links will be in the comments of this video. So in the first part, we introduce into Telos. Telos has objects that are instances of classes. You can have specialization. The green link here is instantiation. Telos regards objects and classes, or regards classes as just ordinary objects. You can also have attributes and relations, like this likes relations. They are also objects from the viewpoint of Telos. So here we have an example of the likes relations. Bill likes Mary, and this likes one link is an instance of the likes link of person. So the principles are specialization, instantiation, and attribution here of Telos. So that is reflected in the schema of Telos, or the predefined core objects of Telos. The most important object is proposition, that stands for any type of explicit information. Objects that you would represent as a node are called individuals, so there are example propositions. Then attribution links or relations are the second type of explicit information. Then instantiation links, they are also regarded as objects, they are also propositions. And finally, specialization links. So we define models as instances of proposition. So these are the names for the things. Attribute is the name of the attribute link. The class individual is this one. Instance of this is a green link. Is a blue link, and proposition is subsuming all types of that information. The dotted green links are instantiation links. So, for example, individual is an instance of itself. Good. Then DeepTelos is defined by an extension of the omega object, the predefined object proposition. In particular, there is now a new link in, which declares an object M to be the most general instance of another object C, the class C. And the rule associated with that says that whenever you have a most general instance M of C and another instance X of C, then the X must be a subclass of M using this is a relation. We also have a predefined is a relation in Telos, which is spelled a little bit differently, but they have the same semantics, and we only use them for technical reason. We only define that for technical reasons. That is, the semantics is defined by 5 predefined rules that were listed in the first example, but you can also look it up in the papers. The link is in the comments. So let's skip with this example and continue with the where we ended with the first part. So in the second part, we start with the use of DeepTelos for extending the entity relationship notation. Antitypes have properties that are linked to domains, like real. We also have relationship types, but that's not shown here. we defined then entity to be the most general instance of entity type. So in a way, these two form a pair that belongs together. The one is for defining entity types, and the other is for subsuming any entity that we have. So this will be a meta class, and this is a simple class, and that's the most general instance. Now we have an instance project of entity type. By the rule that I just discussed before, this is a derived instance of derived specialization of entity. So every instance of project will also be an instance of entity. Let's see whether that is true. That is, yeah, this one here. And likewise, we define value to be the most general instance of domain. So every instance of domain will be a subclass of value. So every instance of such a subclass is also an instance of that class. So value will subsume all values like this number. Finally, the most general instance construct can also be applied to relations and attributes. So for example, the value link between entity and the capital value is the most general instance of the property link of entity type. So since, let's see, this budget here is an instance of property, that's how project was defined. And now by this DeepTelos rules, it should be a subclass of value. Let's see whether that is true. Yeah, so that is also true. So that is the use of most general instances to enhance the capabilities of entity relationship diagrams, to query a database just using the concepts entity and value, for example, so without having to know which schema we are talking about. The next part we will introduce a more complicated case, that is a multi-level hierarchy for satellites, in particular the Galileo navigation satellites. So let's start up the demonstrator. So this is a live demonstration. On the left we have the satellite hierarchy. A satellite stands for any physical satellite. That's the most general instance of satellite model, which is the most general instance of satellite type. Now, satellites are just examples or subclasses of components. So the component hierarchy is a more general hierarchy, and we will embed the satellite hierarchy into the component hierarchy. On the right-hand side, you see another hierarchy of special component types, that is the interface hierarchy. For example, interfaces between USB and 5-pin connectors where you connect onboard computers with some actuators on the satellite, for example. So these are connected. Satellite type is an example component category, and interface type also. So remember this pattern. If you have an instance of this class, then the instance is the subclass of the most general instance of this class. So let's see whether this is true. Yeah, so that is true in the same way here. Yeah, so we continue this game, and then we come to this graph to this model where this is propagated to the lower levels. So since this is most general instance of that, it will also be an instance of that. So then it will be an instance of this object, and consequently a subclass of its most general instance, and so forth. So the whole specialization hierarchies, all the dotted specialization hierarchies are derived by the rules of DeepTelos. Now these are all classes, and this is a simple class. So let's see whether we have some instances. So for example, this is an example satellite. That's the instance 1 of the A1 GeoV satellite model of Galileo. So that is the information system representation, a database representation of a physical satellite that may have some orbit. Let's extend this graph. Yeah, so this was our I1 satellite, which is an instance of satellite. It's an explicit instance of this satellite model. This is a satellite model. It is an explicit instance of the Galileo family, and that's a subclass of satellite model. So it will also be an instance of satellite model. Let's see what that is an instance of. That is an instance of all these things, among others, satellite type. So it's a subclass of a navigation satellite, and that's an instance of satellite type. And we have a rule that if you have an explicit subclass that is an instance of such a class like satellite type, then it will also be an instance here. The subclass of the instance is also an instance of this class. Then if you have this instantiation, then it leads to this specialization. So the instantiation and specializations have an interplay here. Besides the A1 model for Galileo satellites, you have also an A2 model that currently has no instances. We saw this part of the picture before. So due to these specialization links, we have, for example, that this is an instance of Galileo satellite, then also of satellite, then also of component. So component stands for actual components. So this is also an instance of components. Let's see, so it's also an instance of component. Yeah, so that is the instantiation and specialization, quite a number of derived specializations and instantiations due to the DeepTelos rules, and it's all rooted in the relations here, in the hierarchy relations that are declared. The next picture is using some attributes or relations. So the very purpose of the multi-level modeling is to declare the attributes and relations only at the level where they belong to, and then all the objects that are supposed to use these definitions of attributes and relations can use that. Let's have a look at satellite model and satellite. So for satellite models, we can declare a planned orbit, like this example orbit, and actual satellites have an actual orbit. So sometimes they don't reach the planned orbit, and then they are at a different orbit. So this I1 satellite of Galileo is currently at that orbit, It's an instance of Galileo satellite, and all the Galileo satellites have this planned orbit. So this Galileo satellite is on its right orbit. So we define here relations at different abstraction levels. This is simple class level, M1 level, and this is meta class level, M2 level. And you see you can define relations in DeepTelos that go from a meta class level here to simple class level, but also from simple class to simple class. So both works and makes sense, because satellites have orbits, actual orbits, and satellite models also have orbits, the planned order. Let's look at the left-hand side. A satellite model has a start mass in kilograms, which is a number, and this satellite model A1 of Galileo has a start mass of 600. So that is for the model. That's a planned weight of the satellite. Navigation satellites are special satellite types, so instances of that. So also subclasses of satellite model. So let's see. So it's a subclass of this. For them, we specify the power of the transmitter to pass information back to Earth. So that's given in watts, and well, the planned power of this transmitter on this A1 model is 700. So here we define properties of objects that are at the class level, and here we define properties that are at the M0 level, at the object level. So this is the essence of multi-level modeling, that you define the attributes and relations at the right class, and you don't have to have duplicates or redefinitions of these attributes and relations at lower levels or instance levels. So all this work is done by the rules defined for DeepTelos. Let's continue. That's more or less the last slide of this demonstration. That is the part of hierarchy of satellites. Takes some time to load. So the graph file contains all the definitions, and it will be available when you work with that. So this is a live demo. So that we have our example satellite here as, again, this physical satellite that uses physical parts like these parts RW, so-called reaction wheels. So they have some serial numbers, and these are actually the representations of the physical parts. So this is a composition of the satellite at the lowest abstraction level, of the physical level, of the physical satellite. It also has other parts like the gyro subsystems, and that's the gyro subsystem that is part of the of this instance of the A1 Galileo satellite model. Now at the next level, you have the definition of the satellite model A1 itself. So it says it has 3 reaction wheels that are all of this version, so version 45. So 3 incarnations, that is planned at the model level. At the instance level, we have incarnations for these 3 slots for parts of this satellite model. All of them here are instances of that here. So we can see that all 3 of them are instances of this component model that is, let me see, it's an instance of, yeah, this is an instance of a component model. Yeah, at even one more abstraction level, we have the Galileo family of satellites. So this model is belonging to the Galileo family. And there we say how in principle such a Galileo satellite should be produced or composed. So it should have some reaction wheels. We may not know how many. In this case, we have 3. But it should have reaction wheels, and it should have gyro subsystems. In this case we have only 1, but this is one of the parts. Now these part relations, that is planned for the Galileo family. So if we say part 2, then these are the incarnations at the model level. And then they themselves have incarnations at the instance level for this example satellite. Yeah, regardless whether we call that part 1, part 2, or whatever, we want to be able to analyze such compositions just by this has-part relation. So to do so, we declare this to be an instance of the has-part relation. Galileo family is anyway an instance of component type, so it can have these parts, that's this relation. Then we kind of duplicate the has-part relation one abstraction level lower. So this is not the same has-part, it's the most general instance of that has-part. So any instance of this here will then be an instance of the has-part at the component model. So we can use this has-part relation to find out, well, which types of components are related to, for example, the Galileo family, and we can use that relation to ask, for example, which components at this level, at the model level or simple class level, are related to this Galileo model A1. So then we would get these 3 slots and this slot here. Finally, the component also has an has-part relation, which is the most general instance of the has-part relation at the component model level, and that serves to query the parts at the instance level. So regardless whether this here is an incarnation of part 2, 3, and this is incarnation of part 1, we can still just ask, well, this thing is a component, which subcomponents does it have? Yeah, regardless of all this hierarchy above. Yeah, so that's this part. So finally, I would like to demonstrate a query. The code that is generated for DeepTelos. And all the generated rules. So let's this query here. I think it's already predefined. So generated rules. No, it's not defined. So we should be able to copy and paste that here. Well, looks a little bit ugly, but doesn't work. So something is wrong here. The blanks were not copied. So make it. Yeah, here we are again after some copy and paste. The generated rules are the rules that are generated from the DeepTelos rules, and we can ask the system how much work did you do. So you see here the extent of code generation for DeepTelos. So all of these rules are derived from the 5 DeepTelos rules. In particular, it derives instantiation to these hierarchies like interface and component here. Yeah, that terminates the second part of the introduction to DeepTelos. I will put some links in the comments that you can replay this demonstration. Thank you and bye-bye.